that's not all screwed up like I did last period, okay? All right, so today we're going to finish up worksheet 10 and 11. Yes, 10 and 11. And we're going to start looking at 12, I hope. All right? A bunch of what we're going to talk about today, I'm going to be brutally honest, I don't think it's on the quiz, some of it, okay? But it's the kind of questions that they ask on the SAT. That's why we're doing this in this order, remember? Okay? So you need to understand things like how to read a percentile chart and all this kind of stuff we're going to talk about today. Has anybody taken the ACT? Okay, so then it doesn't matter. I was going to say, what they did is they took the ACT and it had a science portion, okay? And they took that science portion, they put some of the questions into reading and some of the questions into math. Because the science portion of the ACT used to be all about reading material and analyzing it and analyzing graphs. So they put the graph piece into the math and, well, actually I think the SAT came first and so they separated it differently when they wrote the ACT, but whatever. So that's the bottom line is there's only two components, reading and math, right? More than two tests. We'll talk more about that Monday, but all right. So please don't sleep through this lesson, even though some of this is not on the quiz was kind of my point here. One of the things we didn't get to yesterday was talking about bimodal data, which means it's split into clusters. So what's happened is that this is an example, I don't know that you have. The annual cost of tuition for a sample of 20 colleges that showed up at a college fair was this. Okay, this is the cost of going to these colleges. They put it in and they split it into a histogram. And this is what they got. This would be considered bimodal data because it clearly separated itself into two sets. Does everybody see that? Anybody have any ideas about why a bunch of the colleges would be down here and another bunch of the colleges would be up here in price? Yes. So these are probably the private colleges or universities, and this would be more like your state schools. Okay? All right. Because they decided that each of these sets, that combining them would give an, if you just find the mean of all those, that's not a very good predictor, right? Because the mean's going to be somewhere in here. So what they did was they separated this and found the mean of this set and then the mean of this set. Would that make sense? All right. I'm not going to talk anymore about that. We're going to talk about skewedness. Now, I need to go back and grab a slide from yesterday. Give me 1 second here. This one maybe? Where are we at? All right. So yesterday we talked about this, remember? Left skewed was when the mean, the average has been dragged to the left. Right skewed is when the mean or average has been dragged to the right from the middle, okay? The median. So today we're going to talk about box plots some more. And on a box plot, I was trying to put both of these on the same screen. On a box plot, this means the left whisker is going to be much longer, okay? And possibly the left side of the box. It just means that the median, where's the median on a box plot? That would be important to know. The median is the middle of the box. Have we not talked about this much yet? let's do this slide first, okay? When we say a 5-number summary, it means we want the minimum, the lower quartile, the median, the upper quartile, and the maximum. Under one variable stats, the calculator will find all those things. So if you go to one variable stats, you put in a bunch of numbers, go to one variable stats and do this. Does everybody see this little arrow right here? It means there's more stuff. You just have to scroll down. And if you scroll down, you will get this, which is literally the 5-number summary right there, done for you. Okay? You can also get the 5-number summary by turning on the box plot and tracing along, because the minimum is always the left whisker. The first starting of the box is the first quartile. The median is the middle of the box. The third quartile is the end of the box, and the maximum value, if it doesn't have an outlier, is at the other end of this whisker. Okay. The difference in between here and here, which would also be called the length of the box, right? If we figured out how far apart those values were, it's called the interquartile range, and it's used to define what an outlier is. We'll talk more about that in a second. I want to go back here. So the median here, okay? The median is in the middle of the box. When there's a lot more to the left, dragged out further apart on the left, then it's negatively skewed. When the median is here and there's more dragged out on the right, then it's positively skewed. All right. There is a question about skewed on the quiz, and you have to actually put the data into your calculator and then decide. So you're going to need to know how to turn on one of these two kinds of graphs and decide. Okay. Now, moving on to talk about this. I want to do a quick box and whisker totally by hand. So this is the dumbest question. A shoe store employee designs a display by placing shoe boxes in 10 stacks. The number of boxes in each stack are 5, 7, 9, 11, 13, 10, 9, 8, 7, and 5. Wouldn't it make more sense if we were talking about like the size of the shoes, because we wanted to find the average size of, I don't know, just weird. But anyway, put those in order for me real quick. 5. There's another 5. What else we got? 1 7. 2 7s. Then what? An 8. 9 9. 10, 11, and 13. Okay. So what the calculator does to find the median is puts them in order and picks out the middle one. So which is the middle of these, guys? Well, the middle would be right here. So the median is going to be 8.5. Now, all Q1 means the 25th percentile. It sounds all complicated. It's the middle of the middle. The middle of the bottom half here, not the middle of the middle. I don't know what I just did. So what's the middle number on this bottom half? So this is Q1. What's the middle of these numbers? Out of those specific numbers, the middle one is 10. That's Q3. Okay? And the min is 5 and the max is 13. So I just want you to one time ever in your life to make a by hand box and whisker plot here. What I want you to do is draw a little line and mark off some even spaces. Like call this 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I do that right? They're supposed to be evenly spaced, okay? All right. You can do it right on top of there. I'm going to do it just slightly above here. But my box and whisker plot would start where? The min is the first thing you graph, the start of a whisker, and that whisker goes until the box starts at 7. Then the box goes until the median, which is 8.5. Using my scale to line these up here. Then the other end of the box goes from 8.5 to what? 10, which is Q3. And then there's a whisker from 10 out to 13. All right, so that's how you make a box and whisker plot by hand. Now I'm going to show you how to do it on the calculator. Does that seem okay? It's a little bit stretched out to the right. So that is positively skewed, okay? But not much. We can talk about that again in a second, remind me. So to decide for sure if we want to call this skewed, does anybody remember what the big deal was? Are the mean and the median separated, right? Are the mean and the median separated? All right, so this is a nice one to do as a class because it's a nice short list, okay? So can you turn your calculator on and go in and type these numbers into a list? I don't want to erase all my other lists, so I'm going to put them in list 4, but you can put them in list 1. Okay, put in this list of numbers. And it doesn't matter if you put them in what order you want. You can put them in the way they were written originally or the way we typed them in now. Or the way we listed them now, I mean. There should be 10 of them. Are we good? Okay. Now, if you want to see the box and whisker plot, we're going to go second y equals. Everybody ready or not? Second y equals. I need to turn this one off because I only want the first plot on. Okay, so I'm going to hit enter and make sure this first plot is on. Now, this is important. If you wanted to show outliers, which I want you to automatically see any outliers, okay? We want to pick this display type down here. So I'm going to, after it's on, I'm going to turn down arrow, arrow to the right. This one, what was the bar graph actually called? Histogram, right? If you arrow to the right one more time, it's not down, it's to the right. It goes down to this guy. My description of him is he's a robot head with something flying out of his ear. I don't know how else to describe that little picture, but do you see that it's a box with whiskers and then 2 dots? Okay, that's the one you want to pick. Okay, arrow down, whatever list you put your numbers in, I assume list 1, make sure it says that here. Mine are actually in list 4. So I'm going to change that to list 4. Frequency is 1, and the mark just, whatever, it doesn't matter. Okay, how do we get a new window? Zoom 9. All the stats are just Zoom 9. Okay. That doesn't look that skewed, does it? Everybody got this? Anybody need help? Okay. Are there any outliers? We haven't really talked about that yet, but the answer is no, because there's not any little stray dots off to the left or the right. On there, is it different? Okay. Well, you're listed on my list for 126, but we'll look at it later. Okay. I want to do the one number stats real quick. Guys, bars, arrow to the right. Just kidding. Stat, arrow to the right. Stat, arrow to the right. One variable stats, okay? Calculate. What is the mean? Okay, the mean is 8.4, And the standard deviation, if we call this a sample, is 2.5, right? If we scroll down, what's the median? We already knew that. 8.5, right? So the mean and median aren't very far apart, meaning it's not really very skewed. So we could use either one, okay? The one on the quiz where I ask, is it skewed, will be very clearly skewed, okay? But again, you're going to have to put in the data and decide by looking. Anybody tell me real quick how we could look at this differently? What's the other way we could turn it on? Instead of box and whisker, we could go back and do what? The histogram, do a new zoom 9. Do you see that doesn't look very skewed, right? Okay, so there's two ways you can decide. And on the quiz, I put pick the kind of skewedness and describe how you chose. So you can tell me what you chose. I did this and it looked this way, okay? All right, now we're going to talk about that interquartile range business and an outlier. When you have a set of data, like if this guy doing this crazy shoe demonstration, shoe stacks, making a display, if he took and threw in a stack that was 75 boxes tall, would that screw up our data? Okay. And so that would be considered an outlier because it's nowhere near all the rest of the numbers. The definition, the fancy definition of an outlier, guys, is you take the width of the box, or what's called the interquartile range, which is Q3 minus Q1. That's how long is the box. And you multiply it by 1.5. And no value can be more than 1.5 times the width of the box out further to the left or the right. So this is the fancy definition. If you take Q1 and you subtract 1.5 times the interquartile range, you can't have anything lower than that. And you can't have anything higher than this. If you do, it's an outlier. Q3 plus 1.5 times the interquartile range. Just to give you, okay, how big is our box here, guys? It goes from 7 to 10, which is what? The interquartile range then is 3. Oh my goodness, I can't write, can't talk. What's 3 times 1.5? If we do that times 1.5, guys, please pay attention. You get 4.5. If you go 8, if you go from 7 down 4.5, you'd be at 3.5. So if we had a number here that was like a 3, it would have thrown a little star down here to say 3 would be an outlier. How far above would it have to be? 14. If this is 10, okay, 4.5 is that interquartile range times 1.5. So anything above 14.5, if we'd had a 16, okay, that would have been an outlier. Now, if we'd had both a 3 and a 16, it would have adjusted some other things along the way, but we'll go with it. All right. Do you want to write anything down on your paper where it says outlier or not? On your notes, it says outlier, okay? It's at the bottom. It's just a value that is throwing off the rest of the data. Basically, when you put this into your calculator, which is what you're going to do on a quiz, it's going to show up, and I'll show you. Let me put in one number here into my list. I'm going to change this to a 17. And I'm going to change this back to... I don't know what I did. This is what it... Just kidding. Oh, I'm struggling, guys. There we go. Okay, I put a value in that changed. They threw it out here and said this is where, so now I have the minimum is 5, Q1 is 7, it changed the median to 9, Q3 is 11, this end is 13 because I threw a value of 22 out here. That value is just a little box or star or something because it's an outlier. That's what it's going to look like if there's an outlier, okay? So it's a data point that's way out of line with the rest. So if I ask you, is there an outlier on a set of data, could you tell me yes or no? I'm not going to ask you this formula, but could you tell me yes or no? If I ask you on the quiz, is there an outlier? Tell me how you decided. Yeah, you could say I looked at the box plot and there was an outlier, okay? Or however you want to describe it, because you could just say this one data point is way far away from all the rest of them. All right, we're going to do this question. All right, this is where we got so bogged down earlier today. I need you to type all of these numbers into one list real fast. Can I read them? Would that help? Everybody go into list 1. We ready? Everybody go into list 1, clear it out. 8.9, 9.1, 10.8, 10.7, 6.2, 10.5, 9.5. Are we good? We're going to keep going, but okay. Keep going in the same list. 7.1, 12.5, 11.3, 9.3, 8.8, 8.1, 6.2, 9.1, 10.4, 9.6, 7.8, 9.2, 9.4, and 9.0. Okay. The first question says to make a histogram of these. Okay, so we're going to go second y equals, and we're going to turn this back and turn it to a histogram, which was the little bar graphy one. And make sure you have the right, like mine is in list 1. Is everybody ready? Now, you can do a zoom 9. Okay, quit. Zoom 9 to see this. Everybody get a bar graph that looks like that thingy? Okay, I usually hate the way they decide to set up their window. They decided to start at 6.2 and make the little bars each represent a difference of 1.26 miles per hour of wind. Where did they come up with 1.26? Well, how about if we go 6 to 14 by 1? Can everybody change it to 6 to 14 by 1s? So now when we graph, it looks like this. Okay, so if I trace, it says there are n equals 2, means there are 2 cities who had a wind between 6 and less than 7. Above 6 and less than 7. There are 2 cities who had wind between 7 and less than 8. There are 3 cities who had a wind between 8 and 9 miles an hour. Everybody okay? I don't think that data is skewed. I think it's going to be pretty close. Okay. I'm not going to take time to draw this. Does anybody have a question? Could you make this if you're not going to have to draw one on a quiz anyway, okay? Now it says choose the number spread. So can you go to the one variable stats, please? So go, how do we do that? Stat, arrow to the right, enter, mine is in list 1. No frequency list, calculate. Okay, what's the mean? The mean is 9.2, and what is the standard deviation? About 1.5 or 6, okay? Now, if you scroll down, what's the median? The median is 9.2. So, is it skewed? No. If it's not skewed, do you remember what we're supposed to use? Which kind of summary? That's not on the quiz. No. When it's skewed is when you use the 5-number summary. It's okay to just use the mean and standard deviation if it's not. This is not skewed, so we're just going to use the mean and standard deviation. So we would say, and you don't have to write this if you don't want to. I'm not asking you this on the quiz, but most cities averaged 9.2, is it miles per hour wind? Or the average instead of most cities. The average was 9.2 miles per hour with most cities between what and what? Within what? The standard deviation is 1.6? 1.6 miles per hour. So 1.6 between 9.2, after lower than 9.2, what would that be, guys? 8? 7.6 maybe? And what's 9.2 plus 1.6? 10.8? So most cities were in that range, which would be pretty much this middle block, okay? So that's the summary that they would be looking for. I'm not going to ask you that. All right, now this is where it gets a little hairy. Everybody awake? On your sheet, there are some of them that were starred, yes? Do I have the right ones starred? Is Philadelphia? Okay, because I messed this up earlier. What else? There's one more that's I'm supposed to have starred. Atlanta is supposed to be starred. Now they're all right? Okay, thank you. All right, we're going to put them in 2 separate lists and do box plots, 2 comparing box plots. All right, so I want you to go back to Stat Enter. And in one of your lists, you're going to put the unstarred ones. I'm going to read them if that's okay. So you can erase list 1 and put these in list 1 if you want. But we're going to put 8.9, 10.8, 10.7, 10.5, 9.3, 8.8, 8.1, 6.2, 10.4, 9.6, and 7.8. They claim that those are the ones not near an ocean. Okay? Now we're going to go over a list. So list 2. Ready? They claim these are all near either the Pacific or Atlantic Ocean. 9.1, 6.2, 9.5, 7.1, 12.5, 11.3, 9.1, 9.2, 9.4, 9.0. We could have a big discussion about how Atlanta's not near an ocean, or Philadelphia's not on the ocean either, but this is what they put in, so I'm going with it, okay? What? Yeah. Well, Chicago is near a large body of water, that's for sure. Okay. So what we're supposed to do now is talk about side-by-side box and whisker plots. Okay. This is what I need you to do. Ready? I need you to go second Y equals, turn on plot 1 to box and whisker. I don't know if you have it on that right now. So that's this one with the alien head with 2 little dots. Are we good? And make sure you have the right list number in there. I think mine is actually in. Okay. Then, now I need you to go back and turn on plot number 2. So go back into second Y equals and go down to number 2. Turn that one on. Okay. Arrow down and go over until you get to the same alien head with things coming out his ears, robot head, whatever, and make sure this one says list where your other list is. Yours is probably list 2, right? Okay, if you've done all that, you should be able to go zoom 9, quit, and then zoom 9, and see this. It is a hot mess. You're right. Okay. Did anyone else get this? These little dots are all outliers. And that is supposed to be the ones that are near the ocean. Okay. Let me just talk through this real fast for you. The middle of the boxes are roughly lined up. Okay. But the data for the ocean ones, with the exception of outliers, is super close together. That's why they're considered outliers, because the interquartile range is so tiny. They're all lumped together. If you look at the yellow ones, guys, 9.1, that's the ocean ones, right? Yeah. 9.1, 9.1, 9.2, 9.4, 9.0, and 9.5. Are those all really close together? Okay. And then they had Anchorage, Boston, Honolulu, and LA are these outliers out here. Everything else was super close together. Okay. The other data is more spread out. Not really, but it's more likely close together. Okay. The middle 50% is more spread out, which is the width of the box. All right. Just so you've seen that, you know what it's comparing. Okay. The medians are roughly the same. That's all I wanted to talk about on that. I'm going to talk about percentiles for just a couple minutes. All right. Yes. If you picked the one that didn't show outliers, this would be connected and it would look like that. Yes, because then it'll know if there's outliers. Okay. Anybody else have a question about that? All right, guys, we want to talk about percentiles. Percentile does not mean percentage. If you get a 60% on a test, you could still be in the 80th percentile. Does anybody know what I'm talking about? Okay. Or for example, okay, so I get, yes. If I gave a test and a 60th percent, you got a 60% on the quiz, okay? But you were at the 95th percentile in the class, what does that tell you? Your teacher's bad. You're not very smart. Well, I don't know about that. You were at the 95th percentile, so compared to everybody else, you were smart. The test was too hard. I don't know, right? But it tells you something. If a 60% on a test put you at the 95th percentile, okay? That means compared to others taking it, you scored, only 5% scored higher than you, okay? A percentile is a comparison. A percentage is just out of 100. So this question, guys, real fast. Percentages are not the same as percentiles. If a student gets 85 problems correct, it's an 85%, okay? It doesn't compare high or low compared to the rest of the class. So they took the GPAs and they broke them into little groups. Everybody who had 2 to 2.25, there was 10 people in that category at Ashland's School of 200 students, okay? So these were their GPAs. Then they said, okay, the first 10 had this. Then the next 28 had from a 2.25 to 2.5. So a total of 38 students. Guys, you're going to have to do this in a second. Then there were 30 students who fell in this category. So they added those on. 10 plus 28 plus 30. We're now up to 68 students. You're getting a cumulative frequency. They divided them all by 200%, 200 students, I'm sorry, changed them to percents, and then they graphed it. This is what you have to be able to do on the SAT. If I gave you this and I said, what, if you have a 3.5 GPA, how do you compare to the rest of the school? Yes, you're at like the 85th, we'll go with percentile, okay? So 15% of the students in this school are above that. Guys, look at this. What's the 50th percentile? So half of their students are below a 3.0 and half are above a 3.0, okay? So that's just, you would have to be able to read it, okay? We're going to do the same kind of thing real fast with this data. This is about a particular test score, and 3 people got between a 55 and a 60.5 on the test, okay? So that's just a frequency of 3. But the cumulative frequency is what we're putting in this column right here. So if 8 people got this score, we're up to how many people altogether? Okay? 12 got this score. So now if we add those 12 in, we're at 23. 5 people got this score, we add them in, we're at 9 people got this score, we add them in, we're at 37. So there's a total of 37 people, okay? So that's going to be the 100th percentile when we get there. But we're going to divide these by what? 37, yes. So 3 over 37. Guys, help me out here. 3 divided by 37, roughly 8%. Okay. What about 11 divided by 37? About 30%. 23 divided by 37, 62. 28 divided by 37, 76%. Okay. Now we're going to graph these real fast. It's hard because these are boundaries. So the middle of this would be like, I don't know, 57-ish. So at about 57, you hit 8%. Put a dot. At about 62, you hit 30%. 62, 30%. At about 67, you hit 62%. Big jump right there, right? At about 72, you should be at 62%. Did I just do that wrong? Shouldn't this be over here? Score of 70. 67 was at 62%. 67 is somewhere in here. At 72, you should be at 76%. There I am. Okay, now I'm getting better here. And at about a 77, you're at 100%. Okay. It's just to show you didn't start at 0. Okay, so nobody reached a score of 100, right? We don't even know if the test had 100. Estimate the percentile rank of a score of 62. So according to this graph, if I went to a score of 62, I'd be somewhere around the 30th percentile. I'm going to write that differently. 30th percentile. Okay? Be around the 30th percentile. Interpret its meaning. Well, what does that mean? 30% of people did worse and 70% did better. Okay? All right. So tonight, I'm not going to be done talking, so please don't pack up. But you need to do 11B. There at the bottom of 11B are these book assignments. You don't have to do these book problems. They're already on 11Bs. Everybody see them down there? Okay. I want to spend 5 minutes starting to talk about normal distribution. Okay. because we're going to run out of time tomorrow otherwise. A normal distribution is when you have a set of data that is making roughly a bell-shaped curve. It's when the mean, median, and mode are all roughly the same place. Okay? There is an equal amount of data spread out on the left and the right. The curve will say it should be continuous. It'll approach but never touch the x-axis. And the area underneath the curve is 100%. Okay, in other words, all the data points are in there. This is how they come up with something like that. If they had a 400-meter run and they put 100 people's times in, okay, and they maybe separated, this is a 5-second difference. This is from this time till 5 seconds later, 5 seconds later, 5 seconds later, and they lump the people in categories, okay? I'm not like starting at 5 seconds, but there's 5 people in this category. All right, then they gave it to, they had 1,000 people's times in, and they broke the times down a little bit further. And then they put 10,000 people's times in, and they measured by seconds, by every 1 second, how much further, okay? Eventually, it would approach this. So they're estimating that based on this entire population, we'd fall into this kind of a thing. And Miranda would be up here, is that what you're telling me? Are you? And is a huge difference. Okay, so it was probably more like a 1 second difference to start and like a 1/10 of a second by the time they broke the categories down further and further. I didn't, yeah, I would be at the other end of the spectrum, the people who walked it. Okay, there is an equation for a normal curve. Bet even those of you at AP Stats don't know this equation. Isn't that beautiful? Should I read it to you for fun? If you haven't memorized by tomorrow, I'll give you points, okay? It's disgusting. All right, guys. You use, I'm going to make 2 more sentences here. You use the idea of normally distributed data specifically for things like comparing an ACT score to an SAT score, because they're not on the same scale. Does everybody understand that? Okay. But if you can put them in terms of a percentile, then you can compare them, right? If I can say my 32 on the ACT is at the 90th percentile, then my SAT score that my cousin got of 1,500 is only at the 85th percentile, then I can say I really did better, right? All right, we'll talk more about this tomorrow.